In this lesson, we're going to look at graph transformations. The first graph transformation we're going to look at is y equals f of x plus a. Now, the way I think about this is I relate it to either the straight line or quadratic functions. If you have a straight line function like y equals 3x plus 2, this means the intercept is at 2. If we say that y equals 3x plus 5, the intercept is at 5. So the plus value at the end shifts the graph up the way. If there was a takeaway value here, it would shift the graph down the way. The same idea, if you had y equals x squared, that would go through the origin, but if you had y equals x squared take away 3, the parabola would be moved down 3 places. And this works for any function. If you have an add or a subtract after it, it shifts the graph up and down. So let's look at a function here. This is a cubic function. It doesn't really matter what it is. If we have to draw the function with a plus 1, then we shift each point here up 1 place. So this graph would just shift up 1 value. Notice it would be the y values that would be changing and not the x values, because the y values are the values that go up and down the way. So the new graph would look like this one over here. 0, 1 has moved to 0, 2, 2, 3 has moved to 2, 4, and 6, 1 has moved to 6, 2. Also notice that when I'm writing the new values of a, b and c, I'm doing the image of them, which is called a dashed, b dashed and c dashed, so you don't get confused with the original values. So that would be f of x plus 1. If you were moving it down, if it was the takeaway one, it would be down here, and then subtract 2 would be down here, and so on. So it just shifts the graph up and down the way. The next transformation we're going to look at is y equals f bracket x plus a, or x take away a. Now this is very similar to the phase angle you learn in National 5 or Intermediate 2, where things like y equals sine x plus 30 move the graph backwards 30 degrees, and y equals cos x take away 20 moves the graph forwards 20 degrees. So we're shifting the graphs left and right in this case. It's also the same for graphs, quadratic graphs, where you have y equals bracket x minus 2 all squared. That would shift the quadratic forwards 2 places, and if you had a plus 3 in the bracket, it would shift it backwards. So it's kind of the opposite thing that happens. If you've got a plus 2 here, instead of shifting the graph forwards 2 places, then you shift it backwards 2 places. If you have a takeaway 3, then you shift it forwards 3 places. Same idea as before. P, Q and R become P dash, Q dash and R dash. We're drawing in this case the function of f of x plus 2. So this graph here shifts backwards 2 places. The new graph shown over here. So 2, 3 becomes 0, 3 because you're moving it this way 2 places. It's the x coordinate changes this time. The 0, 1 becomes negative 2, 1, back 2 places, and the 6, 1 becomes 4, 1. It's really important that you mark in the new coordinates when you shift the graph. A lot of people shift the graph and forget to put the coordinates in and lose marks. Similar to the phase angles I mentioned before, sine of x minus 30 would move it this way 30 degrees, and cos of x plus 60 would move it backwards, if you like, 60 degrees.